America's tallest new dam in 25 years finally started filling for the first time this spring. A $690 million reservoir built to secure water for about 825,000 people on Colorado's Front Range. On April 21, 2026, water finally poured into the basin, and the moment it did, nobody was allowed to use a single drop of it. The reason is buried inside the dam itself, in the very rock crews used to build it, and depending on what happens next, it might need a second megaproject just to use, a whole treatment operation the reservoir was never supposed to require. To understand how a brand new dam ends up poisoning its own water, you have to start with what that dam is actually made of. The rock it's built from contains uranium. It's mineralized and naturally occurring in the granite that crews pulled straight from the reservoir's own footprint. When water touches that rock directly, uranium leaches out, and preliminary testing points to a real risk that the water in Chimney Hollow will exceed the EPA's safety limit of 30 micrograms per litre. That limit isn't bureaucratic caution. Long-term uranium exposure through drinking water is linked to kidney damage and a raised risk of cancer. That's why no one treats this as a technicality. So a brand new record-setting dam is now holding water the rock around it is quietly poisoning. The people who built it have to get the uranium back out, and how they do that is where this gets complicated. Why pour water into a reservoir you already suspect has a uranium problem? That same day in April, Northern Water opened the valves and did it anyway, but only barely. About 1,500 acre-feet of western slope water, held in Lake Granby since the prior water year, flowed through the inlet and outlet tower into the massive basin. That filled less than 2% of the reservoir. The reasoning was practical. Lab testing can only tell you so much. Northern Water needed real-world data on how uranium behaves once water actually touches the dam at scale. So every week now, crews pull samples from the small pool and send them to a lab to measure how much radioactive material the water is picking up. As of mid-2026, those results were still pending. No mitigation decision had been made, and no water was leaving the reservoir until this gets sorted out. Northern Water has two ways out, and one of them is a lot worse than the other. The leading option is drawdown. Cycle water through the reservoir to physically flush the uranium out of the dam rock over time. Northern Water spokesperson Rachel Stevens has called this the most direct path forward, saying the best way to move the uranium is to draw the water down and force it through. The agency wants a clearer read on the actual uranium levels before it commits to anything. The fallback is the serious one. And to see why it's serious, you need to know how this water was always meant to be cleaned. Normally, water leaving Chimney Hollow flows to the member city's existing treatment plants before it ever reaches a tap. Some of those plants, the town of Superiors for one, already strip uranium down below the federal limit, but they can only handle so much. That's the whole point of drawdown. Keep the uranium in the reservoir low enough that the plants cities already own can cope. If it stays too high, they can't. And then Northern Water has acknowledged the next step could be building a dedicated treatment plant or system below the reservoir itself. Sit with that for a second. A $690 million reservoir, one of the most expensive water projects Colorado has built in decades, might need a brand new treatment plant bolted onto it just to make its own water safe to drink. And this is where it stops sounding like a filter and starts sounding like a second project. Removing uranium at this scale means ion exchange, banks of resin vessels that pull uranium out as water passes through. It's proven technology, but it isn't small. Comparable uranium removal and heavy treatment plants elsewhere have run from the low millions into the tens of millions of dollars to build, and that's before you deal with the part most people never think about, the waste. The uranium you strip out doesn't vanish. It concentrates into a radioactive byproduct that has to be handled, stored, and disposed of under its own set of rules, which means the plant isn't just tanks and pipes, it's a permanent radioactive waste operation running below the dam for as long as the reservoir does. Now, scale that to a reservoir meant to serve most of the northern Front Range, and you're no longer talking about a piece of equipment. You're talking about a facility with its own footprint, its own budget, and its own decades of operation. A second build the original project was specifically designed to make unnecessary. Here's the honest part, and it's what makes this worse rather than better. No one has actually priced Chimney Hollow's version yet. Northern Water has no cost estimate and can't produce one because the testing hasn't gone far enough to say how big the plant would need to be or whether it's needed at all. So the 12 communities that already paid $690 million are staring at an open-ended second bill that could be a few million, could be many times that, and won't come into focus for years. And Chimney Hollow isn't even alone in the fight. Uranium above the federal limit turns up in water systems across the West, Colorado included, and the options are always the same three: find a new source, buy water from someone else, or build treatment. The difference here is that this reservoir manufactured its own uranium problem by quarrying the dam out of the rock that causes it. Broomfield, the largest financial stakeholder, has said through spokesperson Julie Story that these discussions will likely take several months, if not longer. The city also noted that with the drought, it wouldn't have been using Chimney Hollow water this year anyway. So how does a project this big end up poisoning its own water? For that, you have to go back to what they set out to build. Chimney Hollow Reservoir sits just west of Carter Lake in Larimer County, Colorado. It was designed for one specific purpose: to firm up the Windy Gap water rights, giving 12 project participants a reliable 30,000 acre-feet of water per year from a 90,000 acre-foot storage pool. The water gets there through a system most people have never heard of. On Colorado's western slope, Windy Gap diverts Colorado River water and pumps it into Lake Granby. From there, it flows through Shadow Mountain Reservoir and Grand Lake, then enters the Adams Tunnel, traveling 13.1 miles beneath Rocky Mountain National Park and under the Continental Divide as part of the Colorado Big Thompson system, before arriving at Chimney Hollow to serve communities stretching from Broomfield to Greeley. The $690 million figure is the total program cost. It covers the dam itself, which ran between $500 and $560 million, roughly 20 years of permitting, more than $90 million in environmental mitigation, and staff time. All of it came from the 12 participants, a mix of water providers and one power authority, not from general taxpayers. The town of Erie alone put in $44.5 million for just under 7% of the storage. Greeley took roughly 10%, Broomfield holds the biggest stake of all. The build matches the price tag. The main dam stands about 350 feet tall and runs 3,700 feet across the valley, made of roughly 12 million cubic yards of rockfill and 75,000 cubic yards of asphaltic concrete. Then there's the choice that shaped everything. Most rock-filled dams use a clay core to keep water from seeping through. This valley didn't have enough clay for that. So, a workshop of the State of Colorado Division of Dam Safety and 4 independent consultants unanimously went with an asphalt core instead, a technology developed in 1960s Germany, Austria and Norway, with more than 200 such dams running safely worldwide for decades. The result is only the second asphalt core dam ever built in the United States, and by far the tallest. The timeline shows how slowly big infrastructure actually moves. Northern Water and Larimer County bought the land from Hewlett-Packard in 2004, and federal permitting had started the year before. That process ran for roughly 2 decades before a shovel hit dirt. Barnard Construction signed on in December 2019, ground broke in August 2021, and by December 19, 2025, the project reached substantial completion after 4 years of building. A dam this size needs an enormous volume of rock. Rather than truck it in, crews quarried it right on site from inside the reservoir's own footprint, 14.5 million cubic yards, about 4 times the volume of Hoover Dam, with the final blast in April 2025. More than 500 workers were on site on a peak day. Quarrying on site saved a fortune and kept the schedule tight. It also set up everything that came next. The granite that they were blasting and stacking into the dam's shell was the same rock that would later leach uranium into the water. Northern Water first caught the signal during routine water quality sampling. Monitoring had been running since December 2021 under a construction discharge permit, and through spring 2023, concentration stayed comfortably below that 30 microgram limit, often testing under 10. Then heavy rainstorms hit the site in May and June of 2023, and the readings started climbing. By 2024, investigators had traced the elevated levels directly back to the quarried rock forming the dam itself. One thing this isn't: a scandal of contamination. Mineralized uranium is a known feature of Colorado's granite. Radon and uranium turn up in front-range groundwater all the time, and plenty of Western utilities already filter uranium as routine treatment. Nobody dumped anything here. Northern Water's position, from its own field surveys, is that the quarried granite in the dam's shell is the source, though a competing theory blames exposed bedrock at the reservoir bottom. Either way, They built the dam out of rock that now leaches the one contaminant keeping the water unusable. That fact has fueled a real debate about whether this was ever a surprise. Critics, plenty of them vocal across the comment section of every article and video covering Chimney Hollow, point out that mineralized uranium is a well-documented characteristic of Colorado granite. Some go further and suggest warning signs may have existed as far back as early 2000s planning, though nothing conclusively documents that. Their core argument is simpler. If you're quarrying millions of cubic yards of local granite for a drinking water reservoir, the rock itself should have been tested for radioactive minerals before construction ever began, not just the discharge water afterward. Northern Water's version looks different. The agency has said the scale of uranium leaching from the dam rock caught it off guard. That same 2-year clean record is central to its case. Routine monitoring stayed under the limit until the 2023 storms, and lab-scale analysis simply hadn't predicted what would happen once all that blasted, crushed rock met water in the real world. Northern Water has also noted that test results at the quarry site varied wildly, even within inches of each other, which it attributes to how unevenly uranium deposits form underground. Whether this counts as a foreseeable risk or a genuine blind spot is something regulators and the public are still working through, and it isn't settled yet. Now, the cruel part. Chimney Hollow was built to give northern Colorado a safety net in dry years. That was the whole justification for 2 decades of permitting and hundreds of millions in spending. The reservoir was finished at the end of 2025. Months later, as it took its first fill, the Colorado River Basin was already deep into one of the worst droughts on record. All 7 basin states issued drought declarations in 2026. The USDA named dozens of Colorado counties primary natural disaster areas that spring. By April, Lake Powell had fallen to roughly 25% of capacity, with forecasts pointing lower. By June, Colorado's governor had declared a statewide drought emergency and activated the highest tier of the state's drought response plan. And through all of it, Chimney Hollow can't deliver a single gallon. It sits in limbo that could last another 2 to 3 years while dam safety testing continues and a mitigation plan takes shape. It also holds a junior water right on an overstressed river, which means it could be among the first supplies cut if shortages deepen. Gary Wachner of Save the Colorado, whose group sued to stop the project, then settled, argues that any new diversion from the Colorado River makes a dangerous situation worse for the river itself. America needed more water storage. Colorado's Front Range needed cushion against the next drought. What they built looked like the answer, and the dam itself is a real achievement. The asphalt core held. Construction finished on schedule. What nobly planned for was that the rock making up that achievement might keep it from working for years. Northern Water expects the leaching to fade, since there's only a finite amount of soluble uranium in the dam material. That's a fair bet. But no one can say when levels will drop below the EPA standard, and the chance of needing that separate treatment plant hasn't gone away. At its last public update, the reservoir still held about 2% of capacity, while weekly lab tests tracked what the rock was doing to the water. About 225,000 people on the Front Range are waiting to learn whether their investment can deliver clean water on its own, or whether making it usable takes a second project nobody budgeted for. Delivery is still projected for 2027 at the earliest, and only if the uranium behaves the way Northern Water expects. If you'd paid into a $690 million reservoir you still couldn't drink from, what would you want? Wait for the drawdown to slowly work, or start building the fix now? Let us know in the comments, and subscribe for more Mega Build stories.